When maybe when patients undergo surgery, the anesthesiologist must administer the right amount of drugs to the patient to keep them sedated during the procedure. The well-being of the patient depends on the doctor's ability to predict how long the anesthesia will stay in the patient's bloodstream. How does he or she do this? So, first question, what do you think will happen if a patient receives too little anesthesia? Too little anesthesia, they'd wake up during the surgery. Yee, that's not good. What if they give them too much anesthesia? They would die. So, one of those is a little worse than the other, right? They both are pretty bad. One's worse. I'll let you decide which one you think is worse. Look at 2. The concentration of anesthesia in a person's bloodstream can be modeled by, this one's nice. Too much, they said, they will have a hard time waking up afterwards. I'll be a little more straight to the point, okay? 2, the concentration of anesthesia in a person's bloodstream is modeled, there's the equation, where C is given as a percent and T is in hours. A graph of C is below. So what do you notice about the graph? And what do you wonder? So just think about it. This is time, and this is the percentage of anesthesia in their bloodstream. So what do you think is happening over time here? Very quickly, it is spiking. So they are administering the drug here, right? And then what's happening during this time? It's wearing off, absolutely. So there's an initial spike and then a decrease over time. One of the wonders, it looks like it's kind of leveling off. Right? You guys see what I'm talking about? I wonder, are you ever going to get rid of all of it? Or is it somebody going to stay? So, B, what is the concentration of anesthesia after a half hour? So if you wanted to find specifically after a half hour, it tells me T is in hours. So if I want a half hour, what can I do? I can plug in a half. So 35 times 0.5 over 0.5 squared plus 6. Just trust me, you could put this in your calculator, you would get 2.8. So after half an hour, you can see here on the graph, after half an hour, we're at 2.8, which is somewhere right in here, right? It's still going up. What about after 24 hours? What's the concentration? Well, we would just do 35 times 24 plus or over 24 squared plus 6, which again, just trust me, is going to be 1.44. What about after 48 hours? 35 times 48 over 48 squared plus 6, which is going to be 0.72%. So from 24 to 48 hours, we lost about half of it. Right? So what if this just continues? Every time we double the time, we lose half the anesthesia. Everybody good with what I'm doing? I know I didn't make y'all plug that in. You could plug that in. 3, anesthesia is considered effective at a concentration at or above 5%. So how long should the surgeon wait to start the surgery? And how many hours is the anesthesia effective? So if anesthesia only works when it's at 5% concentration, think about this line here. So it looks like it's about an hour. After an hour, it becomes effective. And how long is it effective for?
6 hours. 6.
Well, it looks like it's effective until around the 6th hour. But if you couldn't start it until hour 1, 5 hours of work.
You have a 5-hour surgery?
Yeah.
I had a 20-minute surgery sometime and they put me under anesthesia.
Yeah, some people have very long surgery, especially like open heart surgery, or if you're having like a heart transplant. Those surgeries take a long time. A lot of stats they have to do. 4. After many, many hours, what do you anticipate will happen to the concentration of anesthesia? After many, many hours, after 100 hours, or 500 hours, or 1,000 hours, how much anesthesia do you think would be in their blood? Like not a lot. Like basically zero. So we expect it to go to zero or really close to zero. Right? That says go to zero. I know it looks like 60. But that's go. Go to zero. So what we're essentially saying is, if I want to put that in math terms, what's happening? The limit as x approaches infinity of f of x is equal to, what are the y's getting close to? So this is our first limit we've done that doesn't go to infinity or negative infinity, right? But it's getting closer to zero.
Are we about to start learning how to use limit notation?
We already have. 5. For large values of t, which grow faster, the numerator... Sorry, let me read that again. For large values of t, which one's going to grow faster? The numerator or denominator? So if you look back here at our equation, as t gets really big, which of these numbers is going to be bigger? The numerator or the denominator?
Denominator.
How do you know?
Because it's squared.
That's correct. The denominator has the higher degree term. And so it dominates at the infinities. You guys remember talking about this with polynomials? That the end behavior was all based on the highest degree term. That's still true here. And so the denominator would dominate.
Domination.
And then how is your answer in question 5 related to the long run effect of anesthesia in your body? Well, think about how fraction works. So if the denominator is getting bigger than the numerator, what's happening?
If the number's getting smaller.
Correct. This is some number. This is some bigger number. You're getting a smaller answer, which is getting closer and closer to 0. Right? Because, I mean,
Fraction's just like division.
100 over
Pretty crazy.
10 million. I mean, this is basically
It's
nothing.
a little.
Exactly. So...
Because the top slip.
Uh-huh. What about B?
We don't know that yet. We have to solve it. We don't know how to do that one yet. That was the one we haven't learned. Right? That's the one we haven't learned. Is the top of the
Because the bottom leading coefficient is good.
It's x squared. The bottom one's x squared.
That's correct. The denominator here is x squared. The numerator here is
X to the third.
x to the fourth.
Oh, yeah. You be it.
So the degree of the numerator is greater than the degree of the denominator. So for right now, we're going to say there is no horizontal asymptote. That is true. It's going to be a different kind of asymptote. But we're not going to do that. No. We'll talk about vertical asymptotes later. Don't even think that. It's not vertical. It's an oblique asymptote.
That's like
That's not
right
fair.
here. Ain't it?
Oblique is like right here, I thought.
Yeah, we're not that oblique. 2, write an equation of a rational function, g, where the limit as x approaches infinity of g of x will be 4/5. They'd have to be equal, give me the next word, equal degree. So I need to create a polynomial that is equal degree. You guys tell me. I don't care.
G of X.
4x squared over 5x squared. You're simplistic. That's fine. That works.
Plus 7,
Plus 7.
and then at the bottom could be plus 8.
No,
Wow.
it couldn't. What?
Yeah. It doesn't matter. It's just the leading coefficient.
The highest power term is the one that matters.
The leading coefficient is the only one that matters. Yeah.
But in part B, you didn't give the leading coefficient.
I did not.
Because
Why is that?
Because the degree of the numerator was not equal to the degree of the denominator. In part B, the degree of the numerator is 4.
Yeah.
The degree of the denominator is 2. So the degrees were not equal. So it has nothing to do with leading coefficients. Only when the degrees are equal. Okay? Here's another one. What about this one? Could I do...
you probably do 20 over 25. Because it's both times 3.
That'll reduce to be 4/5, which is... I'm just stretching your brain a little. Okay? Sweet. 3. A rare species of insect was discovered in the Amazon rainforest. To protect the species from extinction, entomologists transferred a certain number of insects to a protected area. The population of a new colony, T days after transfer, is given by, there's the function. What's the y-intercept of P of T? So where does the y-intercept happen?
0.
When what do you mean 0?
Horizontal asymptote.
No, stop. We're not doing horizontal asymptote. This is back to your polynomial days. When the x is 0. When the x is 0, we get the y-intercept. So here, plug in 0 for t, right? Because t is my x. And so these terms would cancel, and I would be left with 50 over 2, which is...
I thought you have to do 25 over 0.01. Because that's in front of T.
Exactly.
I plugged in 0 for t.
Because 25 times 0, Cam, is
I know, but
approximately
why?
0.
What are you asking? 25 over 0.01?
Yes.
We're not doing horizontal asymptote. That was not the question I asked. Read the question, right?
We're trying to find the y.
The y-intercept, where it crosses the y-axis. So what does the y-intercept represent here? Where x is 0, so give me context. What is x even talking about?
The
Time.
population of the new... How many days until the new population
Should be in a-
forms?
Population after 0 days.
Which after 0 days would mean...
There's 25 bugs.
What I started with in the beginning, right? So yes, after 0 days means I've just recently transferred them. I just have moved them over. And so I had 25 insects at the beginning. I don't know if I spelled that right. Just go with it.
So they took 25 and put them in the rainforest.
They took 25 from the rainforest
And put them in a protected area.
and put them in a protected area.
Okay.
That's what we did in Mr. Coach Barker's class.
That was none of your guidance.
B. What's the limit as t approaches infinity of P of T? So as my days grow towards infinity,
It's gonna go up. As
25
P.
over 1. Or 50 over 2.
What? It's either infinity or negative infinity.
why?
The limit was
Because-
just
That's how it always
4/5 on the last one.
Oh, no, it's not.
That's how polynomials are. Polynomials are always to infinity or negative infinity, but this is not a polynomial. This is a rational function,
As T.
which means I'm really asking as my x's get really big, what is the y value is going to approach? Well, it's going to be that horizontal asymptote. So where's the horizontal asymptote here?
25 over 0.01.
Yes.
Would be 2,500.
That's correct.
What?
I was
Oh,
on track earlier when I said that. I knew I was cooking somewhere.
We did leading coefficient over leading coefficient because the degree of the numerator was 1. The degree of the denominator was 1.
Why can't they put the leading coefficient in the lead and quit putting it in the factor?
Right, because it's t to the first and t to the first. So because the leading coefficients are the same, I'm going to have a horizontal asymptote at y equals the leading coefficient over the leading coefficient. And if you put that in your calculator, it's 2,500. 25 divided by 0.01. Now, what does this mean in the context of the problem? As t approaches infinity, the y values go to 2,500. So
That's-
what?
The bugs quit at 2,500.
What do you mean they quit?
They quit making more bugs.
Would they quit? Make it? Does that? They get so many they just quit making them.
Maybe there's too many that they.
Maybe they take them out.
Right. They may. It may not can support their population in their current situation.
Might not be enough space.
But you're right. The population is capped at 2,500 for this colony. That's correct. They wouldn't all just stop. If they all stopped, then they would start. Their population would tail off. But they're just reached a max capacity,
They're dying as fast as they can reproduce.
essentially,
Oh.
for either no food or nowhere to stay or.
Instant sacrifice. After every baby's born.
Okay. Am I good to not write that down? Can you write that down and me not write it? I don't have a lot of room. That'll be a disaster. 4. Here's the graph. It has the same end behavior as what? So when I'm talking end behavior, all I care about are what? The leading coefficients, the highest degree terms. Not necessarily coefficients, but highest degree term. What's the highest degree term of the numerator?
7.
What's the highest degree term of the denominator?
3.
Negative 2x to the third.
There's no asymptote.
So there's not a horizontal asymptote. I agree.
There's a oblique asymptote.
There will be an oblique asymptote. I agree. But it's going to look like this. But that's not a choice.
It should be negative 2x to the fourth.
Why?
Because you gotta do 7 minus 3 and then it's negative because there's a negative in there and not 2 negatives.
It's a division problem. Can you divide monomials? 4 divided by negative 2 is negative 2. X to the 7th divided by x to the 3rd is x to the 4th. We subtract exponents.
It's approximately number C.
D.
D.
Oh, yeah.
We kind of already talked about this. Let's see if we can do it. Look at this function. 1 over x minus 2. They've graphed it for us. What's the degree of the numerator?
Degree of the numerator.
1.
It is not 1.
0.
It is 0.
Because there's no 0 after.
Because there is no x, so there's an understood x to the 0. Because anything to the 0 is 1. What's the degree of the denominator?
1.
So the degree of the numerator is greater than the degree of the denominator. So what's the limit as x approaches negative infinity?
Y equals 0.
It's just going to be 0. The limit is 0. What about as x's get really big? What's the y's getting closer to?
Y equals 0.
And so the end behavior looks like the horizontal asymptote. Y equals 0. And you can see it. They plugged in numbers for you. And they did it graphically. So we can see graphically, as the x's get really small, what's happening to the y values. We're getting closer to the x-axis, which is y equals 0. Same thing here. As the x's get really big, the y's are getting closer to 0.
I remember what asymptotes were now. Like they don't touch the
It
line.
approaches, gets very, very close to, but doesn't get there. So you can see here, we plugged in 10,000, Did we get to 0 yet?
No.
No, but we're really, really close.
So y can never equal 0.
I'm not saying that. I'm not saying that yet.
Well, if
I'm just telling you it approaches it. Okay? Don't say it can't equal it. Just saying it approaches it. Just go with me. Go with me. So the next one. What's the degree of the numerator?
3.
What's the degree of the denominator?
3.
So I have equal degree. So what does this tell me? The limit as x approaches negative infinity should be 2. And the limit as x approaches positive infinity should be. And how are we getting 2?
6 over 3.
6 over 3.
Ratio of the leading coefficient. 6 over 3. 6 over 3.
Does this one have an oblique?
That is not oblique. What's happening? As the x's get really big,
It just looks different, that's all that.
yeah, what's different?
There's
The horizontal asymptote, it's still horizontal, but it's went up 2. Because as the x's get really big, we're getting very close to y equals 2. As the x's get really small, we're getting very close to y equals 2. Here's why I want to tell you it can, when you said it can never be, you said it can never be 2, right? That's the way you explained it. Look at this graph right here. When the x value was 1, we're at negative 3.5. Okay? When the x value was 10, we were at 2.03. So what had to happen at some point? It was down here, it had to hit 2 to go above it.
How?
What do you mean how? That's what happened.
But that's not
To
what
go
I'm saying.
from a y value, oh, I went the wrong way.
Yeah.
I went the wrong way. Yeah. Ignore me. Ignore me. Ignore me. It's a bad example.
Okay.
I went the wrong way. Just completely ignore what I said. You're right. So when it was at 1, we were at negative 3.5. When we were at 10, we were up here, 2.03. But it jumped that part because of there's something happening right here. Right? That's just ignore me. Pretend like that never happened. We'll find one in a second. Here you go. Here you go. What's the degree of the numerator?
Is that an oblique?
Hey, thank you.
That's an oblique.
There's an oblique. What's the degree of the numerator? No. 2. What's the degree of the denominator? 1. So what's this going to look like as x approaches negative infinity or infinity? All we care about are the highest powered terms,
X.
which is x squared over x, which reduces to
Oh, so the limit
X.
is X.
So the limit is x.
Okay, I must sound like that.
Wait, if the leading coefficients were different, do we add them or do we just do it?
Yes, leading coefficients would be in there too.
They're
The whole leading
so
term.
If it was 3x squared over
No, I like the next
over
one.
2x,
over x,
it'd be
it'd be
3x.
3x.
And so we can see here, look what's happening. When the x is 100, what's the y value? Basically 100, right? And when we're at 10,000, the y value is basically 10,000.
Plus 6.
It's just getting closer to whatever x is. So it's acting linear. So this is a line. It's acting linear this time. So this acts like y equals x.
But it doesn't always have to be linear.
Correct.
It could be,
Quadratic or quartic or cubic.
the next one's quadratic.
That's why I can't say it's a linear. So we call it a horizontal asymptote. Why? Because it's a horizontal line. We have to call the other one an oblique asymptote because sometimes it's a line, but sometimes it's a parabola, and sometimes it's cubic. It's just not horizontal. It's a different kind. What's the degree of the numerator?
3.
What's the degree of the denominator?
1.
So I need to treat this as it's going to look like x cubed over 3x, right? Which reduces to
1/3 x cubed is
1/3 x squared.
or x
Because you got a minus.
I have that.
Because this is an understood x to the first, right? So we drop the degree by 1 when we divide. X to the third divided by x to the first.
I like the linear obliques better.
And do you see how that's what's happening in...
Like, can you explain to me this though? Why does the graph have a quadratic and a cubic?
What does it have, a what?
A quadratic and a cubic. Shouldn't it have a linear line and then a cubic? Because it's 3x minus 5, which would be linear.
Don't get... No. Don't start thinking that way. We'll talk more about...
You know what I'm saying?
Yeah, we'll talk more about what it looks like later. Right now, we're just talking about in behavior. As the x's get really big and x's get really small. We'll worry about all the garbage in the middle later. Okay? Not yet. Everybody's follows what I'm saying there? We're thinking about at the ends. What's it look like? Do you guys feel good about this, or should we do more of like that? Can you guys find in behavior? Like if you look at this page, do you feel good about being able to identify all of those?
Yes. The first one? Yes.
What's the first one?
Yes.
Y equals 2. Horizontal. Y equals 2. What's the second one?
Wait.
We're looking at the same thing?
0. Y equals 0.
Second one's Y equals 0. Third one is?
Wait, the second one, how?
X.
Well, second, what do you mean how? So no, we're not good, so we need to do more of this.
No.
It's
I was looking at the
It's
fourth one.
x cubed.
Are you looking at this? Are you looking where I'm looking? Is this where you're looking?
Oh, no.
Okay, well there you go.
Third one is y equals 1.
Y equals 1 for the third one.
Second one is y equals x, or fourth one is y equals x.
Y equals x for the fourth one.
Okay, the third one is oblique.
Y equals 2x.
2x for the fifth one.
Wait, I thought it was oblique.
Yeah, it's y equals 2x, which is
2x, that is oblique.
And then y equals x squared.
Yeah, for 7. Is everybody okay with all of these?
Wait, what's third? Is it just 1?
Y equals 1.
Is that oblique or
No. It doesn't have, hey, if it doesn't have a variable, it's just a, I mean,
Okay, look at the next page. See if we can fly through it. Hopefully I've done enough of the teaching. Oh, that's so blurry. I'm trying.
This is the page I was looking at.
1, does it have a horizontal asymptote?
Yes.
Yes, where is it?
3 over 2.
Y equals 3 over 2. 2, does it have a horizontal asymptote?
No.
No.
And it is.
I don't have to do it. It don't care yet. You're right. It's going to look similar to y equals 1/5 x. 3, does it have a horizontal asymptote?
Yes.
Where?
0.
Well.
The degree of the numerator is less.
Oh, I'm gonna get so confused on the test.
That's why you got to get these rules down. 4,
Yes.
it's not horizontal.
Wait.
Because the numerator is bigger than the numerator.
That's right. So it's going to be an
Because
O.
3 is bigger than 2, Cam.
Wait, number 5?
I'm on 4.
No, I went ahead.
I got you.
No.
What's the equation for 4?
Y equals 3x.
3x.
I thought we were talking about 5, that's fine.
5, does it have a horizontal asymptote?
Yes.
It does, because the degree of the numerator is going to be 2, and the degree of the denominator is also going to be 2. So it's going to be horizontal. What's going to be the equation? Well, the numerator is going to be what? 10x squared. And the denominator is going to be x squared.
So
It's going to be y equals 10. See, I didn't care about the other terms for the end behavior. I just cared about the highest degreed one. Here, the numerator is going to be what?
4.
X to the 4th. The denominator is 3x cubed.
So no.
So not horizontal. It would be at y equals 1/3 x.
No.
No?
On 7. No.
Yes,
No, on 7.
yes.
Oh, you're right.
7 should be yes.
And it's going to be at 3?
No,
Or 2?
9x.
9x squared is the numerator.
So 9 over 2.
That's right. Y equals 9 over 2. Ooh, nice. I like this one. 8.
Yes.
Yes, it's horizontal. What's the numerator?
At approximately -1 over 1. So
We
negative
gotta
1.
solve this one.
Negative 1. If you do x times negative x, that should be negative x squared.
Oh, okay.
And the denominator would be x times x, which is x squared. So it's going to be at y equals -1.
Nine is no.
9 is going to be no. The numerator is going to be
To the 5th. And
x to the 5th. It's going to be 4x to the 5th
And then put third on
and x to the 3rd, which means it's going to be at 4x squared. Right? Just so you guys know, these oblique ones that we're finding right now, these are approximate. All right? There's actually more terms we can find. So this is not the exact way to find these, but we're getting close enough that it's okay for now. Okay.
Wait, I thought it was called limit notation.
It is. It is.
It could also be called limit notation.
Yeah, they just want me to give the statement. In limit notation, the limit as x approaches infinity of f of x is equal to
-1?
-1.
Yes.
Why is it -1? Because there is a horizontal asymptote at y equals -1.
I have a feeling that the next one just needs to be skipped.
Why?
Because
Let's don't skip it.
Vertical asymptotes.
There are vertical asymptotes, but I don't care about those yet.
He's asking about the.
As the x's get really big,
It's 1.
as the x's get really big, what's the y's getting closer to? 1. That's all I care about for now. All that junk in the middle, we've not learning. We're just learning in behavior. As the x's get really big and the x's get really small. That's because there's a horizontal asymptote here at y equals 1.
On this one, there's no oblique asymptote.
It is an oblique asymptote.
It's going to be x.
x
It is going to be x.
1 over 2, I thought. No, 1 over 1.
What?
F of x equals 1.
That next one's going to be -1.
Yeah, 1x here.
Yes.
Does it go
The next one's not -1/2.
-1/2 x.
Close.
No, it's approximately.
Can anybody tell me the equation of this oblique asymptote?
3, wait, 1, 2, 3, 4. 1/4? -1/4? It goes rise. No, it's run forward. Run -1. No, -2. So 1, 2.
You're just making my brain hurt. You're saying so much.
Yeah, negative.
I said that, Jack, but he said it was wrong.
So the slope, I agree with you guys. The slope is -1/2.
Yeah.
I agree with that. But that's not the equation of that horizontal or that oblique asymptote.
Wow.
Negative 1/2 x plus 1.5.
It's not 1.5. You're on the right track, but it's not 1.5.
It,
Oh, maybe it is. It is 1.5. I take it back.
Wow. Equals negative 1/2 x.
I'm just going to put 3 over 2. That way I've got. So what's different here? The y-intercept.
Yep.
You can see the y-intercept's at 1.5. Whereas here the y-intercept was at 0. So when I'm writing the equation of a line, I have to know the slope and the y-intercept. That's not changed from algebra 1. mx plus b. Right?
I'm gonna roll this.
wait, why is it plus 1/2? Why is it plus 1.5?